circuit diagram. DA available with a wide range of specifications specified by the manufacturer. Some of the important specifications of resolutions: accuracy, linearity, monotonicity, conversion time, and settling time. Resolution is which have to be a clarity of an work which is to be defined as an analog output voltage levels can be provided by the DAC. This is the accuracy, linearity, monotonicity, and the conversion time and the settling time and the stability. These are the things which have to make a conversion of a DAC to be maintained clearly. Accuracy is a change of an actual converter and the ideal converter output. Linearity error is the maximum deviation in the step size from the ideal step size. Monotonicity, a digital to analog converter, is said to be monotonic if the analog output increases for an increase in digital input. When D by A converter doesn't satisfy the condition described above, then the output voltage maybe decreases, and the conversion time, it is the time taken to the DA converter to produce analog output to the given binary input. So this is a digital to analog conversion. ADC is a conversion of an abstract precision number, and typical DAC converts the abstract number into the concrete sequence. Resolution, here the resolutions, this is the number of possible output level DAC depends on the design to the reproducibility of a value, and the maximum sampling frequency, this is measured by the DAC circuit can operate the still produce the correct output. And monotonicity, this refers to the ability of DAC output moves only in the directions input moves. These characteristics is important when DAC used to lower frequency. By this topic, binary weighted resistor, digital to analog converter. Here the binary resistors of an employee, the characteristics of an inverting summer op-amp. In this type of a DAC, the output voltage is inverted sum of all inputs. So here we are having 4 resistors, each one to be a ladder circuit to additional values. So R2R circuits, and here we are having 4 resistors which is connected series to the LSB, and 2 connected with the binary and 1 connected with the MSB. To balance this, and we have feedback resistor across the operation amplifier. We could take out the DAC circuit notified to use the single input resistance value by the connecting multiple resistors together. So inverter or the current mode DAC. As the name of an inverter, the DAC operates based on the ladder currents. The ladder formed in the resistance are in a series path, and the resistance 2 are in the shunt path. The current are given by the value reference value V reference by 2, or I is equal to V by R. So we can calculate the current by I2 is equal to U by 2, I3 U by 4, and I4 U by 8. Using the bits of an identity, we can have the system to be calculated by these the derivation. 2 contents of them complement each other, potential must be used as current and voltage converter. Advantage, the major advantage of current mode D by A converter is that the voltage change across each switch is minimal. So this is an voltage mode DAC. The circuit shows that the voltage mode to be and digital to analog conversion, how it happens. The output of the DAC is obtained from the leftmost ladder, and the input to sequence through all the possible binary mode state. So these advantages of this one is the major advantage of this technique, that is allow us to interpolate between any 2 voltage measure to which need not to be a inverter.